1/4 angle measure. About done. Okay. First thing we need to talk about is a ray. Now, how should you have described a ray? Well, basically a ray, if this is a line, ray is a piece of a line. It starts at a point. And then with the ray, we say, okay, it's going to go this direction, so on, forever and ever. So a ray has a starting point. Even though it's called an end point, it's actually, you can think of, I think the easiest way to think of a ray is, okay, you're going to start at a point, and then the next thing we're going to do with the ray is we're going to tell you what direction to go. So to name this, I'm going to say start, it's a ray that starts at A. You always put the starting point first, and then I say which direction it goes. Well, give me a point it would go through, this ray would go through. And it goes through B. I have described that perfectly. All right? Next thing they have there is opposite rays. Good way to describe this is to have this whole line sitting here. Guys, opposite means that, exactly that, opposite. Opposite of white is what? Okay, agreed. The opposite of up is what? Opposite of left is? Okay, exactly the opposite. So if I had a ray that started right here, went that direction, would a ray going like this, you think, be exactly opposite? How would you describe opposite? Exactly the same, just the exact opposite direction maybe? So it'd be on the same line, it would just go the opposite direction, and together, what did these two rays combine to make? A line, don't they? So you'd have a ray that started, let's say, again here at A, this way to B, but then the opposite ray would go what? Through C. So I could make the blanket statement that ray AB, and how am I going to label this one? Well, this has nothing to do with direction. We just write this left to right because the things we write in life are usually done what? Left to right. So we always put the starting point first. The starting point is still what? A. And even though we're going to the left, you always write the starting point first and then the next point to go to. The left to right here has nothing to do with left to right up here. Does that make sense? You always put the starting point and then what point. So that would be an ACR opposite rays. Easy enough, right? Well, believe it or not, you use rays all the time in geometry, but you don't name them. After this test, there won't be many times that you're asked to name ray AB. We'll deal more with segments and lines. But rays are important because when you actually write the definition of an angle, what an angle is when I have two rays. I have this ray right here. Starts at this point, we'll call it B, and then goes to, we'll say, A. Okay, this is an angle. And then when I get to this starting point B, I draw another ray that's not on the same line. Now, so you see how these rays are not on the same line? They're not opposite rays. Opposite rays make a straight angle. But these here, this makes an angle. You're coming along this ray, and then you get to its starting point and you change direction. Okay, how do we name angles? You can do it basically three ways. First way is you name it how you would draw it by using points. Now, what I mean by that is not lifting your pencil up off, or pen, off the paper. First of all, you think we're going to write the word angle every time? We're probably going to use some kind of symbol for that, and this is the kind of recognized symbol for that. Angle. Now, to draw this angle, where would I start? You can say you can start at C. You'd start at C, and then you would go to what? You wouldn't go to A, you'd go to what? And then where would you go? At this point, you change direction, you go to what? A. Or is there another way you could name that angle?
A, B, C.
You could start at A, go to B and C, and you would draw that angle, wouldn't you? Those are the only two ways, using 3 points. Can anyone tell me why? Well, why is angle BCA not the same angle?
Because you'd be cutting through it.
Well, start at B, then go to what? And then go to, did I draw the same angle? I drew a completely different angle, didn't I? So that wouldn't work, would it? Now, in the letters I used here, what stayed the same the two different ways I did it? What was in the middle? B. The reason that stays the same is because that's an important point of an angle. It's called the vertex. I like to say it's when you have an angle, it's the point at which it changes directions and makes a point. You know, you're cruising along right here, and then you get to B, and then you do what? Take a left turn. Agreed? The vertex is that point where it makes a point, and you change directions. So as you can see, that's why B has to be in the middle. With that in mind, because there's only one angle at this vertex, I could also name this angle B. This won't work every time though, and I'll show you an example here in just a second. But when there's only one angle at a vertex, you can just name it by its vertex, angle B. We need to be writing notes down. Well, you guys should already have this part, but never mind, I take that back. You guys need to be paying attention right now. Sorry. You should have your definitions already down, but this I will ask you to write here in just a second. But for right now, pay attention. Now, and we'll talk about the third way here in just a second. What is this ray and this ray? What do you think those are called? They're called the sides of the angle. The two sides together make the angle, do they not? Now, the third way you will see angles named is sometimes they'll put a number right in the middle right there, real small. Now, that doesn't mean that that's a 1 degree angle. Obviously, it's not. What they're saying is that's angle 1 right there. So your third way is you could have called this angle what? Now, this right here, this way, right here will always work. You won't be able to do this in every case. That's why this is the important way. And guys, you'll find that if you don't trace that, and to this day, if I read angle CBA and I look over at a picture, in my mind I go C to B to A. I draw it with my mind every time. I mean, CBA, BAC, BCB, I mean, couldn't it get confusing pretty fast? So you make sure you know which one you're talking about, CBA or ABC, yeah. That's the one. I'm not a complete mathematical genius. I'm not too bad at it, and I've been doing it for just a little while. And if I have to mentally or physically draw it with my pen or mind, I think you guys probably ought to get in that habit too. Okay? Is there any confusion? Would it confuse you where you think the interior of this angle is? Where I wrote the 1 there, right? Inside the alligator's mouth, maybe. That's the interior, and what do you think's the exterior? Out here? And C, B, and A are on the angle, right? Okay, outside here is the exterior, and this is the interior. Any questions on that? Now, the reason you can't name it, you can't name all of them like this, and I'll give you an example why. Everyone look up here. If I said, hey, look at angle B over there, would you know up here, would you know exactly what angle I was talking about? What about down here? How many angles have a vertex of B there? More than that, actually. More than that, actually. Well, there's the 1, 2, 3, 4, 5. Then the straight angle is 6. That's a lot, huh? I don't want a 20% chance of someone knowing what I'm talking about. You can say, when there's no doubt which one you'd be talking about, you can say angle B. You cannot say it here. Everyone still tries to. You want to know why? You want to know why, 99% of the time. Because everyone is too lazy to go up and go, okay, A, B, C. Is that really that bad? It drives me nuts. It's a pet peeve as a geometry teacher. Heck, be descriptive of C, B, D. Draw it. That's not that hard, is it? Give me directions and tell me how to draw the angle you're referring to. Now, you say, well, we could use numbers every time, couldn't we? Can anybody name me an angle there? Or how about angle CBE? Could you name that using a number?
No.
For those of you that wonder, I said C to B to E. Why not? If you tried to, what would be your closest way to be able to say that? Angle 1 and 2, maybe? Well, do you want to be called by your parents' name? Or do you want your own name? Keter, what are your parents' names? Keter, what are your parents' names?
Melissa and Greg.
Okay, you want to be called Melissa and Greg? You'd rather be called Kellen, wouldn't you? Okay, this angle feels the same way. This angle I drew right there is angle CBE, or angle what? EBC. That's the only way to really label that one, isn't there? So you see how the 3 letters will work every time. And once again, all we're doing today is literally a vocabulary lesson or learning to speak a language. They're going to ask you, hey, what's the vertex of angle? If I ask you, what is the vertex of angle 1? What is a vertex? It's a point. So how do we name a point? By putting a capital letter. So I would put a capital B, wouldn't I? Name a side of angle 2. Well, name me a side of angle 2 there.
Shape.
Nope. A side is not just a point. I have to name the whole side. Good try. I would need to say like ray what? BC or segment CB. Agreed? Close. He was thinking right? It's just we need to name a side as a ray or a segment. So I need to name it as such. So you see how it's kind of like talking the language? I knew what he meant there. I'm glad he made it. We said that because I'm able to teach off that. But when it's all said and done, you know, it's speaking the language. You got to be able to do that too. Okay, write that down. Everybody got that? We ready to go on? Yes, no, maybe? Okay, measuring angles. How are we going to measure angles? Well, I want you to look at, I basically drew these from right to left. Don't draw this, watch. As I drew these rays, what am I going in? I'm going in a circle, aren't I? How do we measure? A circle is how many degrees? So doesn't it make sense that we could measure, and no matter how big I make the circle or how small I make the circle, it's still 360 degrees, right? And since really angles go on forever and ever, that's a great way to measure them. And that's how we measure them, along a circle. We measure distance along a straight line, do we not? So we're going to measure angles along a circle. The concept is the same, it's just the method we use for it is different, and the units. So we're going to use degrees. Now, use a protractor for this. I'm going to zoom in here. Let's measure this first angle here, this one right here, angle ABC. What I'm going to do is I'm going to put my protractor right on the vertex, the center of it right there. Now, the reason I'm not really right now is you see that 180 over there? See, we need to make the ground flat. Make sense? So what I need to do is line up that 180 right there perfectly, or that little notch right there perfectly with it. See, obviously this isn't a 180 degree angle. It is when going from left to right, but if I'm starting here and going up, this is 0. So I need to look at the red numbers or the black numbers, you think? The red, because this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. So if I was to measure this angle right here, where do you think I'm at? This is 40, right? How many past 40? Well, I can go up to 50 and go 1, 2, 3, 4, 45? Okay. So this is a 45 degree angle. It's measured along a circle. You'll see me make marks like this and put an arrow. Now let's measure angle DBA. Now, what do you think I leave it like this to measure it? No, I do what? I've got to line up one of the sides perfectly in the vertex right there. Is that about right? Getting close. Okay, how big's this angle? Well, I start at 0, I keep going up, I got to 70, and then that's 81, 2? Okay, so this one is 82 degrees. So that was that angle right there, correct? And this was this angle right here. Can anybody tell me what the measure of angle DBC would be then? Well, let's measure it. Am I lined up just right there? Getting a little glare from that light, so I was trying to get rid of it. We got that measured up there. I'm at 90. We're at 110. That's 130. Maybe back. See, it's hard to get it perfect. But I'm saying it's at 127. This angle from here to here. There's a reason why I wanted to go with 127. Does anyone know? Huh? If I measured these two correctly, why do you think that's 120? It's got to be 127.
Because it adds up.
I mean, yeah, it messes with some people, and there's nothing wrong with it. It messes with you a little bit. You're human. What are we used to doing in life? Measuring along a straight line. If I told you, Coach Stump here in the family truckster. We went for a drive, and we drove 45 miles. And then Cal, my son, says you gotta go to the bathroom. So we stop off at a gas station, and then we drove another 82 miles. Right? How far did I drive? 127. Did any of you have a problem saying 45 plus 82? You know exactly how far we drove, right? It's the first thing that came to your mind because you're used to measuring along a what? Straight line. Is the concept here really any different? Except instead of going along a straight line, I went 45 degrees up. Let my kids go to the bathroom, stop at the gas station, and then we went another what? 82 degrees, totaling what? I know that's corny, but isn't that the same thing? The two smaller parts equal the whole thing? It's just it confuses us a little because this is along a circle, and here we're measuring along a what? Straight line, something we're more used to. Okay? Now, the other thing is, it is not correct to say this. I cannot say angle ABC is equal to 45 degrees. Does anyone know why? You'd think you could, but really, angle ABC isn't 45 degrees. That's the measure of it. I mean, think about it. When I said, remember when we were doing segments, don't write this down, but remember when I said, I wouldn't say AC is 45. I said what? The distance from A to C is what? I wrote it like that. That means distance, right? Well, guess what? Instead of distance here, I'm going to put a little m in front of that to mean what?
Measure.
The measure of angle ABC is 45 degrees. That's how you write measure. You always put an m in front of it. So, for the other one, I'd say the measure of angle what? ABD is equal to what? 82 degrees. Some of you, it may not have popped in your head right away because you needed to come up here with your pen and go A, B, D. Okay, yeah, that's 82. Well, what is the measure of angle CBD? Should that pop into your head? When you look at this, the answer is not very obvious, is it? Would you guys agree? But when you look up here, C, B to D, what is it? I mean, don't get things wrong on a test because you're too lazy to trace it with your hand. You know what I mean? I mean, there's no reason to make that mistake. Any questions? Write that down. Got one more thing and then we're done. Okay, somebody can open that door if you want. Somebody open that door to help it get a little cooler in here. I agree with you. Has everyone got that written down yet? Okay. No. We're almost done. Can you make it 5 minutes? Okay. All right. Look at this. Don't write this down. We'll listen, then we'll write it down and write the assignment up there. What do you think the word bisect means?
Two sections.
In geometry, we're going to say to cut something in half. Kind of bisect it. Exactly cut it in half. That doesn't necessarily what it means in the really real world, but and for us it does. So what do you think a bisector will do in geometry?
You take it from the vertices.
Well, but I'm just saying in general, what do you think a bisector is going to do? If the word bisect means to cut something in half, what do you think bisector is going to do? It's going to be something that cuts something in half. What do you think an angle bisector is? Something that cuts a what? Okay, it's a ray or a line or a segment. Okay, so we're going to say that xt, ray xt, is a angle bisector. What does that tell you? That it does what? It cuts it in half. Okay. Once again, I'm going to go like this. Always helped me. If you don't like doing this, I understand. But I'd always kind of say from there to there is, and then above it I'd write 80 degrees. Because it's hard to label that, what that whole angle is, because there's an angle inside of it, right? Does everyone agree? Okay. How many different ways is there to cut something in half?
Two.
How many ways is there to cut 10 in half? How can you cut it in half? Into what? 5 and? Is there any other way? Is there any other way to cut 40 in half?
20 and
It's 20 and 20, right? Well, I just told you that this cut in half. What do you think the measure
40.
of angle TXY is equal to? And I want to know what the measure of angle ZXT is. So first, make sure you know what I'm talking about. TXY, what's that one? T to X to Y. What's the measure of it going to be? Well, it has to be 40 because this cut it in half. How about ZXT? What is it? So then you come over here and you write 40 degrees, right? Now, can anyone tell me why this is an incorrect way to write this?
Because you don't have that wave on.
What does equal mean? The exact same thing, right? Is TXY the exact same thing as ZXT? TXY is up here and ZXT is down here. But what do you think I'm trying to get at? That they're the same what? Measure or the same size, correct? So what have we learned is the correct, equal is not the thing to say, but congruent. What we should say is that angle TXY is congruent to angle what? ZXT. And what you can, if you want to say equal, you say, what do you think? The measure of angle what? TXY is equal to the measure of angle what? ZXT. See the difference? because what is the measure of TXY? What is the measure of angle TXY? What's the measure of angle ZXT? Is 40 the exact same thing as 40? That's why you can say equal here. Now everybody look up here real quick. Please don't write. Stop. You're going to see marks like this a lot. And real soon you'll get used to what that means. What I am doing is I am marking on this picture that this angle is congruent to this angle. Any other mark, stop writing. Any other mark I make with one arc, I am saying that it's congruent to that one. If you look on page, I think it's 39 maybe. Here, I'll put it up here. This is an even better example of that.
40.
What do you think they're saying here about this angle right here with the one arc? What are they saying about them?
It's the big arc.
That they're congruent. They're doing that with the picture. What do you think? Why is there two arcs here? Because it's not congruent to the one with two arcs. It's not congruent to this one, so we got to use two of them. So we're saying that the ones with two arcs are congruent, the ones with one arc are what? Congruent. Does that make sense? Okay, your assignment. Yes. I'm going to write the assignment up here, and then you guys can write that down and put it in your notes. Your assignment. Pay attention to this. We're going to do all the numbers 1 through 10 and 12 through 29. And we're going to do all those. But we're also going to do numbers 37 through 43, but we're just going to do the odd ones there. But in both cases, we're going to write problems, draw figures, show all steps, and work. Okay?